Today we'll talk about optimizing object recognition for mobile platform with Caffe. There are other frameworks available for deep learning like Dot7, TensorFlow, Theno, Pylearn 2. These frameworks are basically for deep learning for some specific task, like for Google Net is very useful in deployment phase. TOS7 is supported by Facebook, which is used basically for scientific computing. And like TensorFlow is supported by Google, which is basically used for deploying. So these frameworks are used for some particular task where Caffe is basically used by scientists where there is a large amount of data is needed to be processed in a convoluted neural network form. So basically, like if we want to compare the Torch, Caffe, and TensorFlow, so like Torch has more functionality built in and is in general more flexible, and like Caffe is more flexible and modular, so it can be like if you want to train a millions of image, want to train a mostly standard architecture, so we'll choose Caffe in for those particular scenarios. But and like as we already discussed, TensorFlow is best for deployment. That's like even for the mobile application, mobile devices, TensorFlow can be used. But as we have a large millions of image data set, we'll go with Caffe. So what is Caffe? Caffe is an open framework for deep learning, and it is developed by Berkeley Vision and Learning Center. And with Caffe there are many features which comes, like purely developed on C++. It has a command line interface for all your tasks, and it has a well tested code which purely on C++. It has many pre-processed examples and references model which can directly be used without any coding. It has a data management system where you can save the data in different database forms, or maybe in a uh, IMDb or LiveDB, and you can choose between the mode in Caffe. Like you have a CPU mode and GPU mode, which can be like choose by the user, and basically it's supported by a large community of users and researchers which are using Caffe for their open source projects. So basically Caffe can be divided into three phases, where we can develop a prototype, and then we can train the prototype for particular task, and we can develop the output. Like for the deployment phase, we can generate a pre-trained model, and we can deploy it to any of the application we want. So Caffe communities, like it's a open source framework which can be downloaded from GitHub, and there are many like there it's a very active community which has lots of researchers and developers contributing to it. So let's talk about something the futures of like features of Caffe. So in deep learning, uh, like how the models are defined in Caffe, so we have a protoduf text file where we can define the different layers of Caffe. Like this layers are like uh, a human readable form of declaring every layers with some parameters, like how the number of output we want, the kernel size we want, and what type of layer it is, like if it is a convolutional layer or a data layer, how the layers are connected, whether it's a like bottommost layer or the top layer. So all these parameters can be defined in protobuf, which is the main file for the Caffe to read the input and to perform the training and deployment. Okay, so we will use Caffe for running our like our data set will be a CFR data set. It's a Kaggle data set which have 60,000 of images. So it is divided basically into 10 classes of object like airplane, automobiles, bird, cat, deer, and every class has a 6,000 images. So total it has a 60,000 of images which are well defined by put by Kaggle. So we'll use cipher 10 data set uh, for training our model so that we can deploy this model to our Android application. So like it's very simple in like Caffe, how to take this model and like how to run it. So it's already there is a prototext file for the Cipher Caffe where which have like basically three layers like data layer and then convolutional layer and the loss layer. So data layer is described in the quick train test dot prototext as given in the this slide. It is basically take the data from a CFR train, IMDb, and and there's a convolution layer which take the data from the data layer and run the convolution model and generate the output. And that there is a loss a softmax layer which will basically perform the probability of the object or the image process image. So once this prototext file is ready, we have to define our prototext solver file where basically we have to describe how it's a small file where we have to describe like from where the prototext file from which the data has to be run. So we have to define our network prototext layer and then how many iteration we want to run. So like for this case we are running for the 100 iteration, and like how many testing intervals has to be done. So this parameters has to be set in quick solver prototypes, and we have to set the parameters for the our formula like for base learning rate is 0.001, momentum is 0.9, and weight decay is 0.004. So all these parameters are set for the training purposes and testing. And finally, when these two files are already defined and set, we can run the command for train quickset dot shell script. So it will run and generate the all the pre-trained model for our cipher 10 data set. So basically when the training in progress, it will look like this as a output which will show us the like what is the parameter for the loss rate and what will be the accuracy of the test network. So all this data will be seen in the our std output. So how the deep learning cafe model looks like after the all these trained models are done, the cafe will generate uh, the output files of a cafe model which is a binary file, and a trained model which can directly be used in uh, other devices. Like we for our project purpose we are going to use it for Android application, and we'll deploy this output generated file dot cafe model to our Android application, so that we don't have to train the data in the application. We can directly use the output file for running our mobile application. So it's easy to integrate and deploy the final output of Caffe to other applications. Even it is very easy to use this Caffe model for from some other command line tools, or maybe from Python or MATLAB. So this modularity of Caffe is very good, which can be utilized from the other application and running the training and the learning model in some other place, and doing the application in like client side. So the main what we are talking about, this transfer learning, which is basically like uh, doing a training the model on some lots of data set, like for this case we run our learning model on cipher 10 data set. So what we had done is we had generated a output of weight, which can be used to train new data. Like for this case, if we have a given set of data like ImageNet, and we have a convolutional network for training the data, we'll train the data and transfer the weight to new data. And this can be done easily by changing a few lines of code in model prototext file. And the performance from this is like, with, you don't have to train the data from scratch. You can utilize the training from already existing data set where you have trained your model earlier. You can utilize the train model, and you can train your new data which you want to train, and then the accuracy of the new data will be more higher, and it will be more faster than the doing it from the scratch. So this is basically the fine tuning part of the Caffe, where we can like take a pre-trained model and fine tune it to the new task. Like basically we are taking the model whatever we are generated for cipher data, and then we are fine tuning it for our mobile application, so that it will perform more in our mobile application. And even if we want to take new pictures or new images from mobile phone, we can directly um, uh, fine tune this new data on our already pre-trained model. So basically, when this fine tuning is needed, so there are some things which is needed, while if you need a less data or a faster learning rate, or you may need a more optimized model of your pre-existing model. This fine tuning part will be useful in this part, which results in more optimized detection or segmentation or recognition. As per our mobile application is concerned, as embedded system has low processing power, so we need the fine tuning part, so that we can utilize the more optimized model in the phone, so that it will be more faster and more accurate for like embedded devices.